Hi there, this is Dr. Satish, Assistant Professor at British Applied College. I welcome you all to this video lecture. This is for ENG208 Mechanical Principles, Level 4 Pearson Higher National Diploma students. Now, in this video, we will be looking into how to draw shear force and bending moment diagram for simply supported beams with different loads. I will explain an example with a point load and a uniformly distributed load and a uniformly varying load. Now, if you look into this figure, we have a simply supported beam. So, two reaction forces at RA and RB, and we have 2 kilonewton and 4 kilonewton. 2 point loads acting at two different points. Now, if you want to draw the shear force and bending moment diagram for this beam, first what I will do is, let me make projection lines at different points wherever it is needed. Okay. Now, if you look back into our lecture slides, this table shows for a point load. Let me show you. For a point load, the shear force diagram should be a constant line, that is a horizontal line, and a bending moment diagram should be linear. Okay, so we will be following that. Now, so for a shear force diagram, let me draw a baseline. Let me use a different color, maybe a blue one. I will draw a baseline. Okay, and I am going to follow the left side to right hand side rule. So upward shear force will be positive, downward will be negative. So I am following left to right. So when it comes to shear force, upward will be positive, downward will be negative. So here you all can see at this point, okay, at this location it is 2.8 kilonewton upwards. So this is going to be on my positive side. So I will go upwards 2.8. okay, just it's up to your own scale. Okay, this is 2.8 upwards. Now I have to be following a constant line after this as per the table. I'll be drawing a constant line. After I reach this position, if you see, it is 2 kilonewton downwards. Okay, so already I am in the scale 2.8. Please remember, I am traveling at 2.8. Now I have to come down 2 kilonewton. Okay, so I come down by 2 kilonewton. So this position is supposed to be 0.8. If you properly understand, so 2.8 minus 2 is 0.8. Okay, so then I travel again in the constant path and I come here. If I come here, the 4 kilonewton acts downwards. Okay, so this allows me to go further down to the negative region. So far I was following the positive, now I go to the negative region, and this is supposed to be 3.2. Then I travel horizontally and I reach point B. If I reach point B, again it is upwards 3.2. okay, so remember I am in the negative region, minus 3.2. so if I travel upwards 3.2, I will reach 0. Okay, so please remember, for a simply supported beam, the shear force diagram and the bending moment diagram starts at 0. Okay, it starts at 0 and ends at 0. Okay, this is a clear indication, so please remember this. So now this is my positive region, so you have to understand, and this is my negative region. Okay, and when I go to, this is as far as shear force diagram is concerned. This is as far as shear force diagram is concerned. When I go for a bending moment diagram, let me draw using a different color. So if I go for a bending moment diagram, then please understand, here I have to follow two rules. One, the slope, okay, whether it is positive or negative, it depends upon whether the shear force is positive or shear force is negative. That is the first rule. The second rule is whether it is going to be a constant line or a linear or a second degree parabola or third degree parabola. That depends upon the table. If you go to the table for my point load, this is linear. You can easily see that. Okay, this is linear. So let me go back to my part. So what I will do here is I will start here from 0 when I move here, this is positive slope. Okay, see, whenever I start moving from one point, I have to understand whether I should move in the positive direction or in the negative direction. It depends upon this slope. Okay, so now I will start my positive direction. So my positive slope, let me redraw this. So I'll be traveling in my positive slope and I will reach this point. Okay, now let me look into the shear force diagram. It is again in the positive region. So what I will do here is I will again move further upwards. Okay, and I reach a maximum point. Please understand, the maximum point is always where the positive and the negative region crosses over. If you see here, this is the point where positive goes to negative. Okay, so at this point the bending moment will be maximum. Please note this. And now there is negative slope, so I come down. Okay, so this is how I complete the shear bending moment diagram, and this is my positive region. Okay, and this is my shear force diagram. Now if I go further, this is for a point load. If I go for a uniformly distributed load, I'm going to continue the same. I'm going to draw the projection lines. And let me, which color I used? Blue one. So let me go for a shear force diagram. This is my baseline, and I start from here. This is 12 kilonewton. Okay, so I go up 12 kilonewton. This is my 12 kilonewton. Then after I travel horizontal, please remember this. This is a very interesting question. See, someone can argue, okay, when I have this uniformly distributed load, the shear force should be linear. Okay, but still the uniformly distributed load is not coming into action. Okay, when I travel here, it is still under the action of shear force of this reaction. So we should travel horizontally till we reach uniformly distributed load. Then we go for linear, then we go again horizontal. Okay, this is how the shear force diagram is going to be. You look into it, and once I reach point C, okay, my uniformly distributed load comes into action. When it comes into action, then what happens is I have to draw a linear line, and see, this is upwards, shear force is upwards if the load is upwards. Okay, so if you see here, this is upwards, so I am drawing, I am moving up. Okay, but this, okay, this effect is downwards, so I move down. Okay, please understand that. Now I will be moving down, and this, see the total load. For example, if I see here, the total load will be 10 kilonewton meter into 2 meters, so it will be 20 kilonewton. Okay, just multiply with distance, so it will be 20 kilonewton. So already if you see, it is positive 12 kilonewton in the positive. So if I apply this load, the final result will be 8 kilonewton, because 12 in the positive plus 8. Okay, so totally 20, all the 20 total load will be applied. Okay, so I follow here and I reach 8. Okay, so this is my 8 kilonewton point. Okay, now after the uniformly distributed load is done, I again travel horizontal and I reach here. At point B, I have 8 kilonewton reaction force, so I again move to the top and I complete the problem. So this will be my positive, this will be negative region. And if I draw the bending moment diagram, you can clearly see for uniformly distributed load, it should be second degree parabola. Okay, so it should be second degree parabola. So what I will do here is, here when I start from here, okay, I look into the shear force region. This is positive, so I am going to travel positive slope. That is my first point. And this is linear, please, this is constant. So now my bending moment will be at this region will be linear. This it is linear. Okay, so if the shear force is constant, my bending moment will be linear. If my shear force is linear, then my bending moment will be second degree parabola. And if my shear force is again constant, then it will be linear. Okay, this is how my bending moment diagram will look like. Now if I go here, let me use this, so it will be positive slope because positive region, and this is constant, so it will be linear as per the table. Now what I will do is I will go here and I will reach maximum. Okay, I will reach maximum at this point. Please understand, wherever it crosses over positive region to negative region, that is the point where I get maximum bending moment. Okay, so this is the point where my maximum bending moment is. Okay, similarly if I look into this diagram, this is the point where my maximum bending moment is. Now negative slope. Okay, so please understand, here in this diagram also, till this point I follow a positive slope. Okay, I mean second degree parabola positive, this is second degree parabola, until from after this I follow second degree parabola negative slope. Okay, please understand that. Now again if I look into my shear force, it is negative region and this is constant line, so I will be following a negative slope and linear line. Okay, so this is my, you can write like this. Okay, this is my second degree parabola and this is a linear line. Okay, linear is not need not mention, but second degree parabola you can write it. Okay, so again it starts with 0 and ends at 0. So this is my bending moment diagram for a uniformly distributed load. Now if you look into uniformly varying load, like this, then my shear force and bending moment diagram as per the table, it should be second degree parabola, the shear force, and third degree parabola for bending moment. Okay, so if I look into this part, maybe let me draw the projection lines. Okay, fine. Okay, now if I draw the shear force diagram for here, this is my shear force line. Now as we saw in my previous lecture videos, how to find the reaction forces for uniformly varying loads. Okay, you will understand the intensity of the load, okay, for example if I take this part, this load, then it will be 1/3. Okay, 1/3 from here, and the intensity of this part, okay, this portion of the load will be 1/3 from the head. This is 1/3. Okay, 1/3 from the head portion and 2/3 from the tail portion. So this you saw in my previous lecture videos. Now when I start drawing here, what happens is, again you start from the left to right. Okay, so I have 15 kilonewton. Please understand, 15 kilonewton, so I go up 15 kilonewton. Okay, so maybe this is my 15 kilonewton. Now the total uniformly varying load because of this, okay, the total uniformly varying load is 30 kilonewton. So what happens is, I have to draw a second degree parabola as per the table. So I will go here and I will reach here. Okay, so please understand, the total load is 30 kilonewton and initially I have 15. So negative, it would have, at this position it would have reached negative 15 kilonewton. Okay, maybe I can write it negative 15 kilonewton. Now at B position we have a load 15 kilonewton, so it goes up again, it goes up and it reaches 0. So it starts at 0 and it ends at 0. Please understand that. And this is my positive region and this is my negative region, and you can write, okay, this is my second degree parabola. Okay, now if I draw the bending moment diagram for this, then again the same thing. The first rule is whether it is positive slope or negative slope. If you see my shear force diagram, it is positive slope, so I will be going a positive slope. If I go for a bending moment diagram, okay, as per the table it should be third degree parabola. Can you see, for a uniformly varying load this should be third degree parabola. So I will come here and if you look properly into it, I will start here and this is a third degree parabola. So what I do is I start like this, I reach my maximum, then again I reach here. Okay, see here, this is my positive slope, okay, because the shear force is positive. This is my negative slope because my shear force is negative. Okay, and this is my maximum bending moment. I can write this maximum bending moment, and I can also write this as third degree parabola. These things you can make, okay, and this will be my bending moment diagram. So I didn't solve the reaction forces. I already solved it to save time. You can look into my previous lectures to find how to calculate reaction forces for different loading conditions for different beams, okay. Now that's it from this video. Thank you. Let me also see you in the next video.